The question goes like this. A tent is in the shape of a cylinder surmounted by a conical top. I have given the rough sketch for the description given in the first sentence. If the height and the radius of the cylindrical part are 7 meter each, that is, the radius is 7 meter and the height is also 7 meter, and the total height of the tent is 14 meter, that is from the top of the conical part to the base of the cylinder is 14. From these information we can get the radius of the conical part and the height of the conical part. The radius of the conical part is the radius of the cylinder, so this is also 7 meter. And for height, let us subtract the height of the cylinder from the total, that is 14 minus 7, that is also 7 meter. Subdivision A, find the quantity of air contained inside the tent, which means we have to get the volume of the space inside the tent. Quantity of air contained inside the tent will be sum of volume of conical part and the volume of cylindrical part, which is 1 by 3 pi r square h plus volume of the cylindrical part is pi r square h. On adding these two, we get 4 by 3 pi r square h. On substituting the values for r and h, r is 7 and height is also 7. So we get 1437.3 meter cube. Part B, find the radius of the sphere whose volume is equal to the quantity of air inside the tent. Volume of sphere, the volume of air in the tent. Let the radius of sphere be taken as capital R. So it is 4 by 3 pi capital R cube is equal to volume of air in the tent is 4 by 3 pi R square h. On further simplification, we get R cube is equal to radius is 7 and height is also 7. This implies radius of the sphere is 7 meter. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos.